Okay, here you go. Integrals of logarithmic, and exponential functions. The integral of e to the x dx is equal to e to the x plus c. Any surprises there? Nope. How about this one? The integral of 1 over x dx is equal to the natural log of x plus c. Any surprises there? Now, here's something that we say. If the function that you're taking the natural logarithm of could be negative, then you need to put absolute value signs around it. So, for example, could x minus 3 be negative? Could you plug in a value to make that negative? You can't take natural value or natural log of a negative, so therefore you have to put absolute value signs around. What if I had x squared, natural log of x squared? Can x squared be negative? No. So you don't need to. So you don't need to have the absolute values in that situation. I'm going to show you one more that might come up. The integral of a different base. So say it's not e. The integral of b to the x dx, if it's a different base other than e, the antiderivative is still b to the x, but you divide it by the natural log of b. If you remember when we took the derivative, we would multiply by the natural log of b. Yep. All right. I want to change this problem because it's a dumb problem. Okay. So let's go. Let's go the integral from 13. 13 will be the top value, and the bottom value will go 8. Of 2 over x minus 3 dx. Okay, that'll be a good problem. Okay. If you notice right away when I wrote it 8 to 3, can you plug in 3? No, so that's why it's kind of a bogus setup from the beginning. But what we want to do is we want to identify u, and u is equal to x minus 3. What is then du? Dx. I don't have dx, I have 2 dx. Yep. So I have 2 du is equal to 2 dx. So I have 2 integral 8 to 13. And what remains? One over u du. What's the antiderivative of 1 over u? Natural log. The antiderivative of 1 over u is natural log, and we have a times 2. So 2 times the natural log of absolute value of x minus 3, evaluated from 8 to 13. So 2 times the natural log of 10 minus 2 times the natural log of 5. So do you remember how you can simplify that? Yeah, good. 10 over 5. So when you're subtracting 2 logarithms of the same base, so in this case the base is e, you can divide the values on the inside. So we get 2 times the natural log of 2. You could also put the 2 up there and say it's the natural log of 4. So you could square it. Or you can move the exponent up. Yes, no? Well, I'm just saying that I don't know which result the AP exam would give you to choose from. Either are acceptable. All right, let's try B. What is u in this problem? Good. E to the x minus 1. It's important that u is e to the x minus 1, not just e to the x. So du is e to the x dx. Do I have an e to the x dx? right here. Okay. So I just make my substitution. I've got the integral from 2 to 4 of 1 over u du, which is of e to the x minus 1 evaluated from 2 to 4. Now, actually, e to the x minus 1, it can be negative, but not over the interval 2 to 4. But I'll just put the absolute value signs there for good measure. We plug in 4, we get the natural log of e to the 4th minus 1. We're going to subtract the natural log of e to the 2nd minus 1. I don't think that the AP exam will leave the problem like that. I think they'll write it as 1 natural logarithm of and I don't think they'll leave it like that either. They'll factor the top as the difference of 2 squares and have the natural log of e squared minus 1, e squared plus 1 over e squared minus 1. And then those cancel. I'm left with the natural log of e squared plus 1. They can be parentheses now because e squared plus 1 is not negative. How about letter C? What should u be? X squared. Yep. It should be x squared. Du. 2x dx. I don't have a 2x dx. I have a 3x dx. 3 halves du is equal to 3x dx. So the 3x and the dx are gone. I have 3 halves integral of 5 to the u du. Or 3 halves times, what's the antiderivative of 5 to the u? Yep, 5u over natural log of 5. So, can I take 3 times 5? You can't do the 3 times 5. U is x squared. The bottom you have 2 natural log of 5 plus a constant. Somebody answer that question? This one's indefinite. No bounds. Yep. Yep. Thank you. So, last question for the bottom. Instead of writing 2 natural log of 5, how else could you write it? Natural log of 25. So, I don't know how to list the answer for the multiple choice. So, yeah, I would say that they probably do like this, but who knows? All right, we'll try to get one in more before lunch. What's u? Natural log of use natural log of x. What is du? 1 over x dx. I don't have 1 over x, I have 1 over 4x. 1/4 du is equal to 1 over 4x dx. Now I have 1/4 times the integral du. So that stuff is gone. What remains? U squared. No, u squared. No, u squared. All right. What is it? Antiderivative? U cubed over 3. So multiplied by 1/4 u cubed over 12 plus c. So natural log of x cubed. Absolute value signs over 12 plus c. Go get some brain food. Yep. Go get some brain food. Okay, so that's where we end off there. We pick up 3 problems on the backside. Sometimes you get a problem like this, and you think it looks rather challenging, but we've seen one like this before. And if you have a polynomial on top and a monomial or a polynomial on the bottom that's of lesser degree, just divide it through. When you divide it through, you get 3x plus 4 minus 2 over x dx. And that's pretty easy to find the antiderivative of. Antiderivative of 3x is x squared over 2 plus 4x minus the natural log of x. Whoop, 2 times natural log of x. Right? That's no big deal for us. So a lot of times you just, rewrite it in a way that's helpful. But letter F, that's a great example. What's that? That's it. Yep. But letter F is a great example where this type of substitution can come in and really be helpful to us. So any thoughts for this one right here? Why did I choose u to be 3 plus cosine as opposed to u to be equal to sine? Yeah, because no. So this is important. When I take the derivative, what happens to the 3? It goes away. So negative du is equal to sine of x dx. 1 over u. So I get negative, what? Now, cosine of x, can cosine of x be negative? What's the largest negative value that cosine of x can be? Negative 1. So if you add 3 to you get 2. So there's no way this inside expression would ever be negative. So therefore, you don't have to include the absolute values. No. So here, you notice I did not write absolute values because it's always positive. It's always going to be 2 or greater. You tell me. Do you? I get it. I've thought about moving it to that section. The book places this in chapter 7. So if you remember first semester, we did derivatives of this kind of stuff. We had to bump to chapter 7. So some of it's just the way the book is laid out. So I'm trying to become less dependent on the way that the book flows and just build it in. But some of it would mean that the thing that's slowing me up, it would make me redo my tests. And that's just, I've gotten lazy there. Nope, good question, because I agree. That's what I would really like to do. So 1/2 e to the x minus 2 plus a constant. Easy peasy. Piece of cake. Upside down.